Welcome to All Things Photonics, a podcast about the physical science of light driving scientific innovation in the 21st century. I'm Joel Williams, Associate Editor at Photonics Media. Join us as we explore the latest trends in optics, lasers, microscopy, and spectroscopy. Each episode, you'll hear from leading voices from across the photonics landscape, brought to you by Photonics Media. With the acclaimed 1985 children's book, If You Give a Mouse a Cookie, author Laura Numeroff raises a hypothetical that would go on to guide a series of similarly pondering titles, including If You Give a Moose a Muffin, released in 1989, and If You Give a Pig a Pancake, which debuted in 1998. On today's episode of All Things Photonics, we apply Numeroff's winning formula for a speculation into the world of optics. If you give a luminary a meta-optic, is our question. Here to answer it, from Boston-based company Metalenz, that's the word Metalenz, but with a Z at the end, is company co-founder and CEO Rob Devlin. Devlin spent 4 years at Harvard University in the group of photonics industry titan, and the luminary of whom we speak, Dr. Federico Capasso. The end of Devlin's time in the group fed into the launch of Metalenz, which today is a leading designer and manufacturer of meta-optics for an expanding number of high-volume applications, ranging from consumer electronics to miniaturized imaging systems. Meta-optics and diffractive and meta-optical elements constitute one of the highest high-growth technology areas in the photonics ecosystem today. Devlin and his partners spun out Metalenz in 2016 at the cusp of the technology's ascension, in 5 years after the release of what Devlin calls a seminal paper describing the wonders of metasurfaces. The potential for metasurfaces remains today, 6 years later, only now it is paired with bona fide commercial successes for Metalenz and its technology. One prominent deployment, announced earlier this year by semiconductor technology ST Microelectronics, features Metalenz's MetaOptics technology in a time-of-flight sensor. Here, Metalenz replaces existing multi-element lenses with a single meta-optic. The company's Metasurface technology bypasses reliance on 3D patterning, as well as light propagation through a lossy material. This distinguishes it from conventional 3D metamaterials, and the cut to complexity enables the company to develop flat optical components that impart both diffractive and refractive type functions in a single layer. As Photonics Spectrum magazine reported earlier this year, that dual functionality can cut the number of components in a dot pattern projector, a complex light structuring module for facial recognition in mobile phones. The mobile phone communication sector is one of several in which Metalenz believes it is ready to drive the next wave of technological innovation. Our interview with Devlin starts with a recollection to 2013, his beginnings in the lab of Federico Capasso, and the ascension of MetaOptics.
I joined Federico's group, I believe, in 2013, and Metasurfaces had already been and had actually taken over as the biggest research activity within his group by that time. There was sort of a seminal paper in 2011 that showed this general concept of metasurfaces as sort of a first implementation of the idea of a metasurface. And the idea there was essentially being able to control all aspects of light, phase, and polarization with just a single layer of material that could be processed through relatively standard semiconductor processes. And so that had actually spawned out of a little bit of an earlier bit of research that Federico had brought with him from his time at Bell Labs in the area of quantum cascade lasers. So quantum cascade lasers, without going into all the details, are sort of a very interesting laser source, but the light that comes out of the facet is very non-collimated and diverging. And so it started with a thought experiment as to whether they could pattern something directly on the facet of a quantum cascade laser, a flat surface, really thin, small form factor that would be able to provide much better collimated light coming out of the QCL. So from that concept, they said, well, actually, the overall idea of single layer controlling light like this is a much more interesting thing and even has a bigger potential impact. And that led to the 2011 paper showing more of just the general concept of this metasurface.
In starting and then growing Meadowlands, the company, you brought us back 10 years and a little bit more, actually, when talking about Dr. Kapassa's time at Bell Labs. And we were fortunate to speak with Jerome Feist on the podcast last season, who had his own QCL-themed anecdotes of that time. Yeah. In starting and then growing the company, was there a specific moment, either a technological breakthrough or a path towards commercialization, sort of emerging, where you said, we really have something here? And the reason I ask, and we'll talk about this coming up in a moment, is that it's not a crowded space necessarily. It is from a technology side. On the commercial side, I think it's still fair to say we're talking about somewhat of an emergent technology.
Yeah, absolutely. And I think the real sort of emergence and actually what led us to spin Metalenz out in the first place was, again, they had these proof of concepts around metasurfaces, and generally the field and in optics, everyone was very excited about the potential of making flat lenses, making really small form factor optics, but there hadn't been, they were very inefficient to begin with. So metasurfaces, maybe 1 to 10% of the light was actually going where you wanted it to after it passed through the metasurface. And so when I joined Federico's lab, bringing kind of the material side of things in, we really focused down on what is the right material, how do we process it in order to improve the performance and efficiency of metasurfaces to the point that you could get 80, 90% of the light going where you wanted it. So when we got to about 2016, we showed the first really high quality images that were ever captured with a metasurface. Everything else had been just focusing light down to a point and looking at how big the focal spot was. But this showed the really first high quality images. And when we saw that was where we kind of had the sort of aha moment that, wow, this can actually be much bigger than just an academic field. And then similarly, that paper that was associated with those images ended up on the cover of Science magazine. And we were essentially getting cold calls from cell phone companies, from lens manufacturers, from investors. And that's where we said, okay, well, I think it's probably time to see if this is going to be able to really be a technology that makes it in the market.
Curious how those conversations go, because on the one hand, you want to play up the hype and legitimize it. On the other hand, you want to really advance the technology to a point where it's viable for the applications that are envisioned. How are you looking ahead when you hear those calls or you take those calls?
Yeah, so there certainly is a lot of excitement when you get calls like that. But at the same time, whenever you're so close to a technology, you know all of the sort of potential pitfalls and weak points as to where the technology is in that moment as well. So a lot of it is kind of building the champions at these companies and organizations, but making sure you're not setting too high of expectations for where the technology is today. So laying out, this is what we can do, and here's the roadmap. So a lot of it is talking about, especially in the early conversations, it's talking about, this is what the technology can do today. Here's where we need it to get, whether it's from the manufacturing side, performance side, for what we think you want to do. And here's our timeline, and this is how we're going to do it. So a lot of it has to do with the overall framing, setting that roadmap, but still you want to stoke the excitement. And so kind of walking that balance is always balancing that is always the challenge.
And right there with you, not just in an adjacent way, but physically, is Federico Capasso. What's it like working with Federico Capasso? Because he is a luminary in this field and in others as well. His contributions are vast and considerable. His expertise is vast and considerable. What's it been like to work alongside Federico Capasso?
Yeah, Federico is a really just a unique individual, and he continues to have sort of an amount of passion that just is amazing, considering how long he's been in the field and how much he's done. And I think that's kind of the first thing you get from working with Federico is it's a contagious passion in terms of science and engineering. And then he also brings sort of that Bell Labs experience again, which, he was there for 27 years and throughout all different great discoveries at Bell Labs. Again, coming back to the QCLs, that was where he, Jerome, and others worked on the QCLs. So he had that sense of not just looking at exploring really interesting problems and questions, but making sure it was close to something applied. Making sure that it was going to be useful for something. And, again, that kind of was contagious throughout the group.
Federico Capasso's influence on optics and photonics extends well beyond Metasurfaces. His pioneering approach to bandgap engineering for heterostructure devices and materials led to the development of the quantum cascade laser. Through his work, he is considered a leading innovator in showcasing the capabilities of MEMS technology. In our Season 5 interview with Jerome Feist, we asked for nuggets about work with Capasso. Feist, a co-developer of the QCL, collaborated with Capasso at Bell Labs in the early 1990s. Devlin, who worked under Capasso more than 20 years later, had this to say.
Federico, in terms of the group and the way he set it up too, in working at Bell Labs with so many talented and brilliant people that came through there, he very much set up his group in a way that he set up an environment that would allow innovation to thrive, but he would allow the students and the postdocs to kind of drive the innovation, come up with the new ideas. So, in the beginning, he would allow you to come up with your ideas, and it was kind of hands off, just set that environment. And then once you got something that was really interesting, he was hands on and almost at times too hands on, you could say. And I'm sure he'll appreciate these stories from me. But if once you got a result from Federico, it was kind of nonstop communication from him, to the point where you'd get an email about a result at 1 or 2 a.m. from him, and then of course you're sleeping in bed, and you would wake up and there'd be a second email that would have come in at 6 a.m. saying, how come you didn't reply to my first email? And I mean, again, this is at sort of the later part of his career after he's already done so much. And that really made it a fun place to work. And the fact that he set it up where you kind of drove your own innovation also sets people up for just the way that they're going to have to work in the real world. And so it was really fantastic. And I could probably have a whole podcast of anecdotes of Federico.
Yeah,
but I think
I'm open to the idea. It sounds amazing.
I think I might get in too deep and get in trouble with him.
Yeah.
So,
well, I mean, do you draw parallels to this? Is there's a bit of grandiosity to this, but do you draw parallels to yourself and where Dr. Kapasa was? Because I mentioned that some of flat optics, MetaOptics, and the commercialization push, a lot of this is emergent, but it's not underwater. We're above ground now. There's more than a toe in the water. And you're really on the front lines of that, you and Meadowlands and a few others too. But do you draw back and look at how he was able to pioneer some of his research and fields and application areas that weren't really yet established?
I think that the biggest thing that I take away from working with him and kind of what he's been able to do, especially as we're at Metalenz now, is making sure you get the smartest people and making sure you set up an environment where people feel open to innovate. I think that's the biggest thing I learned from him, and kind of the parallel that I try to draw at Meadowlands as a company is, even though we are now very focused on product, still setting it up where people feel that open environment to innovate, because that's how we're going to make sure, now that we have emerged and Metasurfaces are in the market, that we continue to stay ahead and at the forefront. And I think Federico, between Bell Labs and what he's been able to do with this group at Harvard, has just been a fantastic mentor in showing how to set up that environment.
Let's talk about commercialization, productization. You brought us back 10 years, 2013, 9 years. And you talked about what happened with you and sort of on the R&D side with materials and some of the R&D developments, the technology. On the other side of that, you have the market, which has grown in such a way that there's now real opportunity to innovate that way. What in your mind has happened in the marketplace that now allows us to talk about the vast potential and real potential for MetaOptics in terms of being productized?
Yeah, I think one of the biggest things, and this comes down to sort of needing to have timing be on your side just as much as having a really interesting technology that can scale. One of the biggest things that happened right as we spun the company out, it was right around when Apple launched their Face ID in a phone for the first time. And so, we haven't talked about this specifically yet, but Metasurfaces in sort of their most basic form work really, really well to simplify complicated optical systems, but for narrowband type sources, LEDs, lasers. And prior to the iPhone, there really hadn't been a mass market for narrowband type imaging. There are a lot of sort of niche forms of narrowband imaging and microscopy and fluorescence and so on, but there really hadn't been a huge mass market. And so one of the biggest driving forces was that when that was launched through the iPhone, all of the other cell phone suppliers then sort of latched onto this 3D sensing, narrowband, near-infrared imaging, as well as then transferring over to places like automotive with LiDAR and so on. So one of the biggest things was that emergence of the narrowband imaging market. And I think that really sort of set a path for where Metasurfaces provide the most advantages, because those systems in particular, whether it's a LiDAR on a car, whether it's a dot pattern projector in a structured light module, or a 3D sensing, a 3D imaging module, they tend to be some of the most complicated systems in phones and mobile devices today. And what Metasurfaces allow you to do is, take 3 or 4 of the lenses and combine all that functionality into just this one single flat layer.
So with MetaOptics, you do have some really kind of innovative, interesting, even novel potential applications in things like remote sensing and beyond that. You've really focused on phones. You just brought it up, whether it's been the polarization imaging advances or the quest to remove the camera bump in the phones. You focused on these smaller devices. Why?
So that's another really big advantage that you get from Metasurfaces, and it starts with phones just in the sense that phones often will drive down the form factor requirements for these complicated optical modules, and then phones will also then drive down the overall cost and price of sensors and other things that need to be coupled with the module. So again, besides reducing complexity, you can use Metasurfaces and what we do at Metalenz in many cases to reduce the form factor. So that's the other, coming back to the market side of things, that's a continual drive in mobile devices for sure, is making things smaller, making them fit into more and more challenging form factors. There's now even the move to put things under the display in phones. And so that's a great driving force and a great way for Metasurfaces to solve pain points. That being said, I think there's lots of markets outside of phones where there's potential applications for Metasurfaces, but also even in the automotive space, there's the push to make things smaller, simpler, less complex. So, but also then coming back to the manufacturing side of things for a little bit here too, when we're getting a manufacturing partner interested in what we're doing, the phone volumes are also really important in terms of having that partner be interested in the overall business as well.
Let's talk about the transfer of technology and that relationship between the market, the commercial side, and the technology side. How evolved is that? How, baked is that relationship now? Because again, we're talking about a technology that is emergent. There's still a lot of potential, things yet to happen.
Yeah, I mean, again, coming back to sort of the timing of things, there's always getting the timing right and making sure that the market is ready for what you're doing, and that there's enough of a burning need within the market as well. Because ultimately, what we have done at Metalenz and what we're doing with Metasurfaces, you're still introducing a new technology. And there's always a risk for these large companies to put a new technology, no matter how great of PowerPoint slides you set up in terms of what you can do and the things that you can do with the technology. There's a risk because they're putting out millions or billions of devices, right? So you need to have that feedback and that timing in terms of they get to a point where there's a really burning pain point and your technology is the way to solve that. And then the risk, they're willing to take that risk. And then also, this is more of just a general advantage of Metasurfaces, which we haven't talked about specifically yet, but the other benefit for what we're doing with Metasurfaces is that we didn't actually have to go and invent a new manufacturing process. So that also helped in terms of adoption by partners and in the market, because we're using standard semiconductor fabs and processes. So the first thing is that need for that burning need from the market side. And then you have to have the manufacturing scale and sort of supply chain security that makes the big customers comfortable.
Has there been a supply chain disruption noticeable for Meadowlands? I mean, anytime you talk about supply chain in the last 2+ years, there's been some wave of disruption. How has it affected you and your ability to manufacture?
So this comes again to another real advantage of Metasurfaces, where we haven't been impacted by, say, the semiconductor chip shortage or anything like that, because if you look at, whether it's a CMOS image sensor or some other form of microelectronics, first of all, these things are pushing sort of the bleeding edge node in terms of features and sizes that you need. There's often even multiple patterning steps that go into making some of the hardest and smallest features on electronics. And then there's often something like 25 or 30 different masks for lithography or layers of materials that are being put down to make, again, an image sensor or some microelectronic chip. With a Metasurface, it really is just one single layer process. So it's about the simplest process that the foundries can imagine when it comes to producing these. And our feature sizes end up being relatively small, smaller than the wavelength of light we're operating at, but relative to the 5 nanometer, 10 nanometer type features that are required for some transistors, it's really large features. So from the supply chain side and the manufacturers, this is a really high throughput process. It doesn't really take up a lot of capacity in those fabs. So it's allowed us to really not see any impact from the shortage because we have such a simple process.
Stops in materials science, electrical engineering, and applied physics sectors have enabled Devlin to put the concepts and theories from his science background into practice in the optical realm. As Metalenz ramps up its focus on product, the company is embarking on a new stage of growth that draws from its ability to use photolithography and CMOS fabrication processes to move manufacturing forward. While the established nature of these methods has helped the company advance production, recall Devlin's mention of Metalenz's ability to withstand supply chain hiccups and semiconductor shortages. Upscaling is a gargantuan task with inherent challenges. For Devlin at Metalenz, the so-called environment for innovation reaches beyond R&D and into the company's next chapter.
Yeah, there certainly was a learning curve in terms of all of the other things that go into mass production. Anyone can go into a lab and make one Metasurface. Any grad student at this point can go into a lab and make one Metasurface. Making 10 million that will perform exactly the same way every time, that really takes a company. That takes a lot of experience and expertise. And that was something I certainly didn't have coming into Meadowlands. And that's where, again, coming back to something that Federico had said, it's always finding people around you, building people around you that are certainly smarter and more knowledgeable. And, what we've been able to do at Metalenz is bring in folks that have already had that experience from, being in industry for a long time. And so even though, some of us early PhDs that were at the company wouldn't necessarily know all of the nuances of reliability and of critical dimension control that goes into manufacturing, we were able to bring in John Graff, our VP of engineering, who had that experience. We've been able to bring in Rich Norton, our VP of ops, who has set up supply chain for various startups and new technologies. So it's that bringing in people that makes the learning curve a lot less steep.
In contrast to the potential size of the market, the opportunity in the market, the number of leading companies or players in MetaOptics right now, it's much smaller than in other technology areas, and that makes sense. Right? It's this new-ish technology, and a lot of the technology is still being pushed forward. In terms of attracting talent, now you've been able to do it. We're conducting this interview at the cusp of fall. You've recently added some executives to your team. How has the attraction of talent been for Meadowlands? Because it is a great opportunity to contribute to something with sort of very high ceiling, but there's also a lot of unknown.
Yeah, there definitely is that additional piece that comes along with a startup and new technology of it's going to be a little bit riskier than a large company. I think the first thing, again, is setting up that environment for innovation. So even though we are pursuing product now, and the key thing for us is to get our Metasurfaces out there, not just in kind of the first set of applications, but the second, third, and so on. So we have to be focused in that way. There's still a lot that goes into new inventions, new ideas. And I think that for really smart people, whether they've been in industry for a long time, whether they're coming out of a PhD, that mix is really attractive. And then what we've been able to do at Metalenz is actually prove that we have put the technology out in market first. So it sets up a little bit more of a stable environment for us now as well, where it maybe mitigates the risk, but keeps that exciting environment here at Meadowlands. And then the last thing is just being in the Boston area where we are. There's no shortage of talent in the Boston area between Harvard, MIT, BU, Northeastern, UMass, you name it. There's just a number of great universities around here for a lot of the PhDs that we're still drawing from.
You mentioned the camera bump a moment ago. There's been a lot written about documenting sort of the end of the camera bump, overcoming this literal hurdle in the phone. And that's something that Metalenz has devoted a lot of time, effort, and had success with. Let's talk about the company in a broader scope. What's Metalenz working on now? Where's the company headed?
I think one of the biggest things we see at Meadowlands is, the Metasurfaces now have been shown to be critical components by Meadowlands in these 3D sensing applications. And we can take existing sensing solutions, simplify them, make them smaller, make them better performing, and allow 3D sensing generally to proliferate as a result of what we can do with our optics. But that's taking basically these known solutions, known modules, and it's a really great first market for us because it's an existing market. There's a burning need, like I mentioned before. But I think what we can do with Metasurfaces now is that this ability to control all aspects and all information in light that you get from the Metasurface, these nanostructures that we're engineering that make up our optics allow us to manipulate all aspects of an electromagnetic wave. And so what we're starting to do, and what is emerging, you mentioned some of the stuff we're doing with polarization earlier, is we're looking at co-designing the full system around the unique functionality of Metasurfaces, or our Metasurfaces' ability to capture information that normal optics, especially in these small form factors, would simply throw away. So we see things like polarization sensing in mobile form factor at a mobile price point as a really interesting emerging use case, where now we're also designing algorithms, image reconstruction along with the Metasurface itself. And there, I think there's a number of applications, whether it be proliferating something like facial recognition beyond just the one major cell phone OEM that is using it today, or even looking at things like enabling more sort of home health monitoring, medical applications that could be on the phone. And I think it all comes down to the fact that with Metasurfaces and what we are doing at Meadowlands, we can bring new information into these systems. That new information then allows you to essentially look at new applications, or in the case where you're working with, whether it be machine vision or anything like that, you're bringing better information into the system to improve the overall algorithms and decision making. So I think that's really where we see Meadowlands going now.
You mentioned automotive, I suppose in passing a couple of times, and a lot of times automotive and energy might be grouped together. Anytime we're talking about a new technology, it's very easy to take a sort of segmented look at the application, or the technology rather, and say, well, it's not in automotive yet. We don't see it in energy yet. Are there any barriers or obstacles? I mean, clearly the company is working hard and is active in trying to get there. Are there any barriers that are hindering the ability to arrive in these sectors?
One of the biggest things, especially when it comes to something like automotive, is just generally coming back to reliability and quality. Automotive always has a higher bar and sort of one of the highest bars when it comes to all of that. So there's just a longer time frame in terms of getting adoption within automotive. The other thing, also from the market side, the key application where we see an entry point for automotive is around LiDAR or at some level in-cabin monitoring or in-cabin sensing. And those markets are still growing and maybe not growing quite as early or as fast as people had originally thought. So, there's still that market lag a bit that is there as well. But from the technology itself, this is one of the advantages of Metasurfaces as well. The automotive reliability, we expect all of that to be easily achievable by our Metasurfaces because we're making these out of all solid state materials, unlike plastic or polymer molded lenses. Our Metasurfaces actually don't change their properties as a function of temperature. So for things like lenses, you don't want the focal length to be shifting all over the place as the temperature is changing, especially for something like automotive, where you have to go from negative 40 degrees C up to 150 in order to pass the qualification. So we don't see any real barriers. It's more a matter of time because there's just a longer overall cycle to getting the technology adopted in that market. And I think, again, Metasurfaces provide really unique advantages there, even more so in many cases for automotive or some of these other areas.
I think limitless potential has been a theme of our conversation. And you mentioned machine vision. And anytime you're talking about in-cabin systems, LiDAR, or really anything where image acquisition is involved, you can veer into that sector. It's not too much of a jump. I mean, are you thinking about machine vision applications? Because that would really open up a whole new, I don't know if new is the right word, but whole additional set of capabilities potentially.
Yeah, we really see machine vision as, and especially in terms of enabling the algorithms associated with those machine vision systems to make better decisions or to make more efficient decisions. We really see Meadowlands as driving that with what we can do with Metasurfaces. Often in these systems, you have some machine learning algorithm that is operating on a very imperfect data set coming in. And so if you're able to bring in more information into the system, whether that be the full polarization spectrum, like we can do with the Metasurface, the full set of polarization information, if you're able to bring in better or more data to the system, then essentially you're able to make these systems more efficient. You're able to make them perform new functions, know more about what it is they're looking at, what it's made up of, how objects are moving, all of those things. And that's really, again, because you can actually parse more information in light with the Metasurface than you can with just about anything else especially in these small form factors that are required.
You made it clear that you're someone who likes to sleep between the hours of 1 and 6 when you can earlier. What keeps you up at night, though? Is there anything that really, in a good way, that really excites you now about the company that we're 10 years in, so to speak, and we're moving forward towards commercialization? I guess a better way to phrase that question is, what are you most excited about here?
I think the thing that I'm most excited about, obviously getting the technology into market has been a huge step. And that's for any new technology, for any startup, that is always one of the most difficult things to do. It's given us a little bit of a chance now. You mentioned sort of the limitless potential, and that's kind of been in the early days of the company, that can be a little bit of a distraction because there's so many things that you can do with Metasurfaces, but you need to really focus and get it in market. And so now that we are in market, it's allowed us to step back and look at some of these more advanced functions. So I certainly think what we can do with completely manipulating polarization information with a Metasurface, bringing a full polarization sensing system to these mobile form factors for the first time, I think that's something that I'm really excited about and often keeps me up in a good way, especially because in polarization sensing and imaging, there are some known applications because this is sat in industrial labs or medical labs, with these tabletop size equipment that cost thousands of dollars. And now we can consider bringing, again, whether it's, home health diagnostics that you could do from your phone, we can start thinking about bringing that to more and more people, essentially giving more people access to this, and ultimately also generating more information and more data that doctors or other folks can go look at. And, I think that piece of it really is something that I find exciting. We see a beachhead for polarization, but ultimately, there's so many different things that you can do with that information once you put it into essentially everyone's pocket. And I think that's a really exciting thing that we're doing now.
That concludes this week's episode of All Things Photonics. Thank you to our engineer, Alan Shepard, and to our news editor, Jake Saltzman, as well as to this week's sponsors. Our featured music is courtesy of betterwithmusic.com. Most of all, thank you, our listeners. As always, you can share your thoughts, pitch us ideas, and let us know how we're doing. You can reach us at allthings@photonics.com. All Things Photonics is available on all major platforms, including Spotify, Apple Podcasts, as well as on our website, photonics.com.